These all are the real numbers except. Well, for get the symmetry, we use the even symmetry or the odd symmetry, and in this case, we don't have even symmetry or odd symmetry, so we don't have symmetry. Well, x and y-intercept. To get the x-intercept is if of x equals to 0 and the point is 2, 0, and the y-intercept is of the x equal to 0 and the point is 0,
Well, to know the vertical asymptote, we have to check the restriction, and the restriction is that x cannot be 1, so we use the 1 in each limit, but at the right and left side. So we substitute the 1 in the original function, and we get these results: infinite, minus infinite, infinite, and minus 1 over 0. And we know that when this happens, minus 1 over 0 is always a vertical asymptote. So a vertical asymptote is when x is equal to, well, to know the horizontal asymptote, we have to use the limit of x approaching infinite. So we substitute the infinite in the equation, and we get infinite over infinite. And we know that when it's a fraction, we have to divide all the equation between the x with the biggest exponent. So in this case it's x. So in the equation, all the numbers and x, we have to divide it by x. And here you can see it. And then we have to substitute the infinite again. Here you can see it. So the result will be 1, and limit of x approaching minus infinite is the same. So both we substitute minus infinite, but when we substitute minus infinite, the result is the same. So we know that the horizontal asymptote is when y is equal to 1. To get the first derivative, we have to use the quotient rule because this is a fraction. So applying this rule, we get this result.
Well, to get the critical points, you use the first derivative, that is this one, and is the equation is equals to 0, and the result is 1 over 0, that is doesn't exist, so we don't have.
Well, in this problem we don't have any test because we don't have critical points.
Well, for the second derivative test, we have this function and we will derivate it 2 times. The first time, when we would derivate it, the answer is this one, but we will rewrite it and it will be like this. Then we will derivate again and the answer is like this, but we will pass this part downwards, so it will stay like this. And to have the inflection point, we will put minus 2 different to 0 and x minus 2 equal to 0. And the result gave us that x is equal to 2, so we have inflection point. And after, with the concavity test, we have the result that the inflection point is 2, so we will put one number that is before and one number that is after 2, and that is 1 and 3. And we will put 1 in the function as it was x, and 3 as it was x. And the answer when we put 1 is positive, so it goes like this, upwards. And the answer when we put 3 is downwards.